The air in the Central Aerohydrodynamic Institute, known by its Russian acronym CHAGI, was a thick blue-gray soup. It was a mixture of cheap tobacco smoke, the chalk dust that fell like snow from overworked blackboards, and the scent of stale coffee and cold anxiety. It was 1976, and within a sealed third-floor drafting room, a dozen of the Soviet Union's most brilliant propulsion engineers were being given a directive that defied all laws of physics, economics, and common sense. The man delivering the news was not a fellow engineer. He was a Tolkach, a political fixer from the Central Committee named Comrade Zhukov. He wore a suit that was too sharp for the shabby surroundings, and his presence alone was a signal of the state's immense, unblinking interest. He did not sit. He stood at the head of the long wooden table, a single sheet of paper in his hand, his voice a low, flat monotone that brooked no discussion. "Comrades," he began, his eyes scanning the room, missing nothing. "The motherland requires a new engine, a triumph of Soviet engineering. You are to design and build the most powerful jet engine in the world. It will be a symbol of our technological supremacy. There are to be no limits on its performance. Your only constraint is time." A stunned silence filled the room. The lead designer, a weary veteran of a dozen such urgent projects, named Arkady Sokolov, slowly removed his spectacles and polished them on his tie. He was a man who had wrestled with the stubborn realities of metallurgy and thermodynamics for 40 years. He knew the cost of such things. "Comrade Zhukov," Sokolov said, his voice carefully neutral, "to what application is this engine destined? What aircraft will it power?" Zhukov's smile was a thin, bloodless line. "That is not your concern, comrade designer. Your concern is the engine. It must be the most powerful, unprecedented. You will have whatever resources you require." The unspoken words hung heavier than the smoke. At any cost. Sokolov glanced at his deputies. He saw the same confusion in their eyes. They had no airframe that could accommodate an engine of such ludicrous power. The Tupolev and Myasishchev bureaus were working on incremental improvements to existing bombers, not revolutionary leaps. They lacked the advanced nickel-chromium superalloys needed for the turbine blades that would withstand the unimaginable temperatures such an engine would produce. The Soviet economy, already groaning under the weight of the military-industrial complex, was in no state to fund a bottomless pit of a project like this. But no one in the room dared to voice these objections. The order wasn't coming from the Ministry of Aviation Industry, it was coming from the Politburo. The men in the Kremlin, insulated from reality by layers of sycophants and paranoid fantasy, had decreed it. To question the order was not to show prudence, it was to show a lack of revolutionary zeal. It was dissent, and in the Soviet Union of 1976, dissent had consequences that ended careers, and sometimes lives. The engine had to be built, even if it made no sense whatsoever. The directive was not born in a vacuum. It was the product of a specific corrosive atmosphere of technological paranoia that had gripped the Soviet leadership throughout the 1970s. The era of détente was a facade, a thin layer of civility over a deep, frozen lake of mutual terror. In the West, the B-1 Lancer bomber was in development, a sleek, swing-wing penetrator of Soviet airspace. But it was the whispers that truly terrified the men in the Kremlin. Through their intelligence networks, they picked up fragments, vague congressional testimony from Pentagon officials alluding to long-range strategic platforms, technical papers from American universities discussing hypersonic propulsion concepts, NATO analysts in journals read obsessively by Soviet intelligence speculated openly about the next generation of propulsion, about engines that could sustain Mach 3 flight, 3 times the speed of sound, for intercontinental ranges. There was no proof, no grainy satellite photos of a mysterious new bomber sitting on a tarmac at Area 51. just a constant, insidious drip of rumor and speculation. But in the paranoid logic of the Cold War, the absence of evidence was not evidence of absence. It was proof of a successful secret. The Americans were so far ahead, the thinking went, that they could hide an entire strategic weapons program in plain sight. A feverish analysis took hold within the KGB and the GRU, the Military Intelligence Directorate. Reports were written, assessments were made. The conclusion was foregone, a product of the system's own innate biases. Quote, "If the Americans might be building a Mach 3 strategic bomber, then we must assume they are. And if they are, then we must have the engine to power a Mach 3 bomber of our own. To do otherwise is to accept strategic inferiority." End quote. It was a classic mirror image fallacy. The Soviets, who ran their own society on a foundation of secrecy and grandiose, state-directed projects, assumed their adversaries operated the same way. They could not conceive that the whispers were often just speculative think tank papers or the boasts of aerospace corporations seeking funding. They saw a phantom, and they decided to build a real, tangible, astronomically expensive weapon to counter it. And so, Project Inné was born. Its mandate was simple and insane. Create an engine that could produce over 55,000 pounds of thrust, a power output that dwarfed anything in the Soviet inventory, with a thrust-to-weight ratio that would shame the best Western designs. It was a technological sledgehammer designed to smash through the sound barrier and keep going, a brute force solution to a problem that likely didn't exist. The project began to swallow resources with the voracious appetite of a black hole. Entire factories were retooled. A special smelting works in the Urals was dedicated solely to experimenting with new metal alloys, consuming tons of rare and expensive metals in a desperate attempt to create blades that wouldn't melt. The best minds from across the vast, creaking Soviet empire were pulled from other, more practical projects and reassigned to Inné. It was a massive, silent diversion of national wealth and intellect, all to chase a ghost, a whisper on the wind, a paranoid fantasy conceived in the smoke-filled rooms of the Kremlin. The engine that no one asked for was now the most important project in the nation, a titanic undertaking built on a foundation of fear. The design that emerged from the ZAGI Bureau, codenamed Project Stormfire, was not so much an engine as a declaration of war against the known limits of physics. It was a monstrous, complex beast of a machine, a Rube Goldberg device of thrust conceived in a parallel universe where material science and economic reality were not constraints. To the engineers who had to give it physical form, it was a waking nightmare. The specifications read like a wish list from a fever dream. The core of the problem was the turbine. To achieve the mandated thrust, the core temperature of the engine would need to exceed 1,700 degrees Celsius, hotter than a blast furnace, hot enough to turn the steel used in conventional engines into molten slag. This demanded new superalloys, a class of materials the Soviet Union had theorized about but never mass-produced. The Metallurgical Institute in Dnepropetrovsk was tasked with creating this miracle metal, a nickel-chromium concoction laced with rare earth elements like rhenium and yttrium. The project consumed the nation's entire strategic reserve of these precious elements, stockpiled for guidance systems and satellites in a matter of months. The resulting alloy, designated Stahl-84, was incredibly strong and heat-resistant, but it was also brittle, hellishly difficult to machine, and cost per kilogram more than its weight in silver. Then came the turbine blades themselves. They were not simple cast metal. They were single crystal structures, grown in special ovens to eliminate the grain boundaries that were points of weakness. And within them, the design called for a labyrinth of microscopic cooling channels, finer than a human hair, through which bleed air from the compressor would be forced to create a protective film of cooler gas over the blade's surface. Drilling these channels required laser-guided equipment that didn't exist in the Soviet Union. A factory in Leningrad was hastily retooled, working in 3 shifts around the clock, producing a 90% failure rate. For every 1 blade that met the impossible standard, 9 were scrapped, a mountain of wasted Stal-84 and incinerated rubles. The fuel consumption was the final gallows humor detail. Preliminary calculations showed that at full military power, the Stormfire engine would gulp down kerosene at a rate that would drain the entire fuel load of a Tu-95 Bear bomber, an aircraft with a range of over 8,000 miles, in under 20 minutes. It wasn't an engine, it was a flamethrower with delusions of grandeur. During a late-night session, surrounded by schematics that seemed to mock them, a young, haggard engineer named Dmitri leaned back in his chair, rubbed his burning eyes, and muttered to the room, "This isn't an engine, it's a metal volcano pretending to be an engine." The joke landed in utter silence. No one laughed, because it was the truth, and the truth was that it wasn't working. The compressors stalled. The turbines vibrated themselves to pieces in simulations. The fuel injectors clogged with carbon after only a few minutes of test runs on subscale components. Yet the money kept flowing. The Politburo, now personally invested in the myth of the Stormfire, saw every problem not as a reason to cancel, but as a challenge to be overcome with more resources, more manpower, more threats. The project was a train with no brakes, hurtling down a track that led to a cliff. After 6 years of design hell, countless revisions, and the expenditure of a sum of money that could have fed a small nation for a decade, a single, full-scale prototype of the Stormfire engine was finally assembled. It was a thing of terrifying beauty, a polished, multi-tonned testament to brute force engineering. It was shipped in a sealed, climate-controlled train car to the most remote testing facility the USSR possessed, a concrete bunker complex known as Polygon 54, buried in the vast, empty silence of the Siberian taiga. The test stand was a colossal structure of reinforced concrete and I-beams, designed to anchor the most powerful engines in the Soviet arsenal. Against it, the Stormfire was mounted, its gaping intake like the maw of a mythological beast. The air in the control bunker, located 500 meters away behind a low hill, was thick with tension and the smell of cold sweat. Chief designer Sokolov, his face a roadmap of stress and sleepless nights, oversaw the final preparations. Fire suppression teams, looking like cosmonauts in their silvered suits, stood by their vehicles. Technicians had their hands on a series of red-painted kill switches, their eyes glued to a wall of dials and oscilloscopes. The countdown began, a calm electronic voice echoing in the bunker. 3, 2, 1, Zapusk. The initial whine of the starter motor built into a deafening scream as the massive compressor fans began to spin. Then the first flame ignited in the combustion chamber, a flicker of orange visible through the inspection ports that quickly turned into a sustained hellish blue. The sound was no longer a scream, it was a roar, a physical force that hammered against the concrete walls of the bunker, making the coffee cups on the console rattle. For 37 seconds, it was the most beautiful thing Arkady Sokolov had ever seen. The telemetry stream scrolled across the screens, showing thrust levels climbing, shattering every previous record. It was working. The metal volcano was erupting on command. It was producing thrust so immense that the very ground beneath the test stand began to tremble. In the bunker, a fine dust sifted down from the ceiling. A crack, thin as a hair, appeared in the reinforced glass of the observation window. The test stand, which was built to withstand enormous forces, was being overwhelmed. It was like trying to test a rocket engine inside a barn. The I-beams groaned in protest. The concrete foundation, which had held supersonic engines without a quiver, began to vibrate at a resonant frequency that the engineers had never anticipated. Cables snaking across the ground 30 meters away from the engine suddenly smoked and then burst into flame as their insulation melted from the radiant heat. Sokolov saw the telemetry spike into the red. The vibration sensors were pegged. He shouted, "Shut it down! Shut it down now!" A technician slammed the master kill switch. It was too late. The engine, operating at the very edge of its physical integrity, experienced a catastrophic compressor stall. The smooth flow of air through the blades was disrupted, creating a shock wave that traveled back through the engine with the force of a bomb. There was a sound that was less an explosion and more the world tearing in half. The Stormfire engine disintegrated. Shrapnel, chunks of titanium compressor discs, superalloy turbine blades, and shredded steel casing screamed through the air, shredding the test stand, embedding itself in the concrete walls, and littering the Siberian ground for a half-mile radius. When the dust settled and the fire crews had doused the blazing wreckage, a profound silence returned to the taiga. The Stormfire was gone. All that remained was a scarred test stand and a crater where its heart had been. It had worked brilliantly for 37 seconds, and in its terrifying success, it had proven itself to be utterly, catastrophically unusable. The Phantom had been given form, only to immediately self-destruct, taking a fortune of a nation's treasure with it into the Siberian dirt. The immediate aftermath of the Siberian test was a scene of apocalyptic devastation. The test stand itself was a skeleton of twisted blackened I-beams. The concrete walls were pockmarked with shrapnel, some chunks of turbine blade buried so deep that they would have to be cut out with torches. Sophisticated instrumentation, painstakingly calibrated and imported at great cost from neutral countries under false pretenses, was now a landscape of shattered glass and melted wiring. The initial damage report, typed on a trembling typewriter in the bunker, estimated the loss at over 40 million rubles, a sum that represented the annual output of a major industrial city. But the shattered test stand and vaporized sensors were merely the opening line of a much larger, more horrifying bill. The real cost was the engine itself. The Stormfire was not just a machine, it was a physical manifestation of the Soviet Union's most scarce and precious resources. The high-temperature superalloys, the Stahl 84, had consumed tons of rhenium, a metal so rare its global production was measured in kilograms per year. The titanium for the compressor fan and casing had been sourced from a secret mine in the Urals, its output prioritized over the needs of the submarine fleet. The hundreds of precision-machined components, each one a masterpiece of Soviet engineering and a testament to staggering waste, were now a glittering field of scrap metal scattered across the permafrost. Replacing the single prototype would require restarting the entire agonizing supply chain. It would mean commandeering another year's worth of rare earth metals, retooling the Leningrad factory for another run of blades with a 90% failure rate, and placing more clandestine orders with Swiss and Swedish firms for agricultural machining tools that were, in reality, 5-axis milling machines for engine parts. The cost to build a second Stormfire was estimated to be greater than the entire yearly budget of the Tupolev Design Bureau, which was responsible for the majority of the USSR's bomber fleet. The Soviet Union had effectively set its own money on fire in a remote Siberian field, and the response from Moscow was not to question the wisdom of the act, but to demand more money, more metal, and more fire. This financial insanity was compounded by a profound strategic delusion. While the engine team had been wrestling with their metal volcano, the parallel project to design the bomber that would carry it had stalled in a morass of impossibility. In a separate and equally smoke-filled bureau, the airframe designers at the Myasishchev Design Bureau had been given the specifications for the Stormfire. Their task was to wrap an aircraft around it. The lead airframe designer, a pragmatic and weary man named Viktor Orlov, had sent a series of increasingly desperate memoranda to the Ministry of Aviation Industry. They were masterpieces of understated technical despair. Memo 34-81. The mass of the Stormfire power plant exceeds the design weight of the entire wing assembly by a factor of 2. The airframe required to support it would have a 0 payload capacity. Memo 12-82. The thermal output of the engine at cruise power would require the development of entirely new heat-resistant skins for the aft fuselage and tail assembly. No known material can withstand this environment for a prolonged duration. Memo 55-82. To achieve the proposed range with the Stormfire's specific fuel consumption, the aircraft would require a fuel load larger than its own empty weight. This is aerodynamically and structurally infeasible. The memos were ignored. The Politburo, having committed to the engine, could not backtrack. To cancel the project now would be to admit that the entire premise, the existential threat of an American Mach 3 bomber, was a fantasy. It would mean that the Central Committee, the KGB, and the entire Soviet military-industrial complex had been spooked by a ghost. The project was no longer about building a weapon, it was about saving face. The engine had to work because the alternative was an admission of catastrophic error at the highest levels of the state. The final crushing humiliation came years later, after the fall of the Soviet Union, when archives were opened and Western documents became accessible. Historians and retired engineers, piecing together the story, found the source of the rumor that had launched the Stormfire. A declassified CIA analysis from 1975 discussing potential future threats had mentioned a theoretical study being conducted in a NASA wind tunnel. It was a paper project, a what-if scenario exploring the outer limits of propulsion technology. Soviet intelligence, with its tendency to interpret all Western research as a direct prelude to a weapon system, had seized upon it. They had seen an academic exercise and reported it up the chain as an imminent strategic threat. The engine, the bankrupting, nation-crippling engine, had been built to counter a threat that didn't exist. It was a multi-billion-ruble monument to paranoia, a titanic effort to answer a question that had never been asked. By 1986, the Soviet Union was dying. Its economy was a hollow shell, propped up by falling oil prices. Grain shortages were causing unrest in the republics. The war in Afghanistan was a bleeding wound. The military budget, once the sacred cow of the state, was now being scrutinized by desperate men looking for anything to cut. Project Stormfire, the ultimate symbol of this profligate waste, was an obvious target. There was no grand meeting, no fiery debate in the Politburo. It was killed with a bureaucratic whisper. A single sheet of paper, marked Top Secret, was circulated among a handful of officials. It contained one sentence: "Further work on Project 84I is hereby terminated." The files were sealed and sent to a vault. The design teams were quietly disbanded and reassigned to more mundane tasks. The Stormfire had flown in exactly 0 aircraft. It had completed exactly 1 test, which ended in its own spectacular self-immolation. In the process, it had consumed enough money, material, and intellectual capital to have funded an entire new generation of realistic fighter aircraft or a dozen scientific programs with tangible benefits. To this day, the few surviving engineers who worked on it speak of it not with pride, but with a kind of awe at its sheer magnificent folly. In dimly lit Moscow kitchens, over glasses of tea, they describe it in the same way. "It was the most powerful engine we never used," they will say, a wistful, bitter smile touching their lips. It was a masterpiece of impossible engineering, and the closest the USSR ever came to bankrupting itself with a single, beautiful, catastrophic idea. It was a phantom pain in the amputated limb of a fallen empire, the ghost of a threat that haunted them into oblivion.